Welcome back. In today's lesson, we'll explore the AWS block storage service, known as Elastic Block Store or EBS. Essentially, either directly or indirectly, you will be interacting with the BS on a constant basis as you make use of the AWS platform more extensively. Therefore, it's crucial to understand what EBS does, how it does it, and what the limitations of the service are. So, without further ado, let's dive right in, as we have a lot to discover. So, EBS or Elastic Block Store is a service that provides block storage for use with EC2 instances. EBS volumes function as unformatted block devices and can be added to EC2 instances behaving as persistent storage volumes, similar to computer hard drives. These EBS volumes are provisioned in a specific availability zone where they are isolated and protected, although there is some built-in resiliency against physical storage device failures. Volumes within an availability zone can fail in the event of a major failure in the zone. Typically, an EBS volume is created and attached to an EC2 instance via storage network. Some storage types allow the use of a feature called multi-attach, which allows the volume to be attached to multiple EC2 instances simultaneously, useful for clusters. However, if this feature is used, it must be managed by the cluster application to avoid data overwriting and parsable damage. Now, as I mentioned earlier, EBS volumes are persistent and are not tied to the life cycle of the instance. Therefore, if an instance moves between different EC2 hosts, the EBS volume follows it. If an instance is stopped, started, or restarted, the volume remains. Data on an EBS volume persists until the volume is deleted. Although EBS is an availability zone-based service, it allows you to create a backup of a volume in Amazon S3 as a snapshot. This data is replicated to be availability zones in that region and is accessible in all of them. This is useful if you want to migrate data between availability zones. Also, EBS can provision volumes based on different types of storage, such as solid-state drives, SSD, and hard or magnetic disk drives. It can also provide different volume sizes and volumes with different performance profiles. The last point I want to cover about EBS is that you are billed using a gigabyte per month metric. So, the price of 1 gigabyte for 1 month would be the same as 2 gigabytes for half a month, and the same as half a gigabyte for 2 months. Of course, there are some extras for certain types of volumes, for certain enhanced performance features, but I'll cover that in the dedicated lessons to follow. For now, let's conclude this introduction with an overview of how this architecture is structured. So, we will start with 2 regions. In this example, one is US East 1 and US West 2, and then, in those regions, we have some availability zones, the A and the B, and then another availability zone in US West 2 as well. Finally, the Amazon S3 service running in all the availability zones in both regions. Now, EBS, as I mentioned before, is based on the availability zone. So, in US East 1, which has 2 availability zones, there are 2 separate deployments of EBS. And that's the same architecture that you have with EC2. You have different sets of EC2 hosts in each availability zone. Now, let's say visually you have an EC2 instance in availability zone A. You can create an EBS volume within that same availability zone and then attach that volume to the instance. Therefore, it is critical that both are in the same availability zone. You may have another instance that this time has 2 volumes attached to it, and over time, you may choose to detach one of those volumes and then reattach it to another instance in the same availability zone. And that's feasible because the EBS volumes are separate from the EC2 instances. It's a separate product with separate life cycles. Now, you can have the same architecture in availability zone B where you can create volumes and then attach it to instances in that same availability zone. What you can't do, and I emphasize again, is you can communicate the cross-availability zone with storage. Therefore, The instance in availability zone B cannot communicate with any volume in availability zone A. It is an availability zone service. Therefore, it is not possible to cross-join between availability zones. Now, EBS replicates data within an availability zone. So, data from one volume is replicated to multiple physical devices in that availability zone. But, and this is important again, failure of an entire availability zone will affect all volumes within that availability zone. To resolve that, you can take a snapshot of the volumes in Amazon S3. And that means that the data is now replicated as part of that snapshot across all availability zones in that region. So, that gives you additional resiliency. And it also gives you the ability to create an EBS volume in another availability zone of that snapshot. You can even copy the snapshot to another AWS region, in this case, US West 2, and once you've copied the snapshot, you can create a volume, and that volume can be attached to an EC2 instance in that same availability zone in that region. So EBS is at a high level of architecture. So, at this point, that's all I wanted to cover. Until the next one,